Hello, everybody. My name is Halo. Welcome to the final part of operating systems, the course, also the final part of page replacement algorithms. In today's video, we're going to be talking about optimal page replacement. If you guys haven't already seen the videos on first in, first out, and least recently used, I recommend you to watch them. But in today's video, we're going to talk about optimal page replacement, what it is, and we're trying to code that into Python as well and wrap all of these things up. So, without any further ado, let's get into the video. So, what is optimal page replacement? Now, this is the same example we've been using for the past two videos. So the frame size is going to be 3. Optimal page replacement, let's go ahead and see what that is. See, initially, this will be 0, right? And then that will be 3. And then this will be 1, right? So what optimal page replacement says is, first of all, it's a theoretical algorithm, okay? Because in reality, you don't really know what the future will have, okay? So you only know what is currently. So this is thing, in reality, you won't have all of this in one time. This is just time intervals, right? So t is equal to 1, t2, t3, t4. So you won't know what comes in the future. But assume you know what comes in the future. What optimal page replacement says is replace that page which does not come for the longest time in the future. What does that mean? Let's say you have 0, 3, and 1. What am I going to replace? Okay, first of all, let's look at 0. Okay, 0 comes over here, 3 comes over here, 1 comes over here. So in the future, closest is 1, then 3 comes, but the latest, the last in the future is going to be 0. So replace the last one which appears in the future. So replace 0. So this would be 2, 3, 1. Now we're looking at 4. What do we have now? You have 2, 3, and 1 now. 1 comes over here, 2 comes over here, 3 is the last one now. So let's go ahead and replace this 3. Okay, so 1 will be, it'll be the same here, no page fault. And let's go ahead with 3. So when 3 is there, none of these 2, 4, or 1, none of these appear. I mean, 4 appears in the future, but the other 2 doesn't. So let's just replace any one there. So this will be 3, 4, and 1. And again, 0 we're replacing. We can again replace any one. So I'm just going to replace 3 here. So there'll be 0, 4, 1, 0, 4, 1. Now let's go ahead and count the number of page faults in this case. So there'll be 1, 2, 3, 4, 5. Same. And then there'll be 1 here, 1 here. So 1, 2, 3, 4, 5, 6, 7. So page faults is going to be 7. Okay, so let's go ahead and see how we can do this in code and what that looks like. Okay, so let's go ahead and create a function for optimal page replacement. Take processes as input and the frame size also as input. There, what are we going to do? See, we just do the opposite of what least recently used is doing, right? There we are checking in reverse. Here we're checking which is the highest index from whatever process is left. Okay, that is it. As simple as that. Let's go ahead and create the tracker itself. So that will be the same as what we've been doing for the other videos. For in range of frame size, and then I will do for I in range of len of processes. Okay, once I'm done with this, I am going to go ahead and set the number of page faults to be 0 so that I can go ahead and track all of this. Now for I in range len of processes, okay, what I'm going to do is I will set the process to be processes of I, which is again the same thing as before. And then what am I going to do? Well, I'm going to copy the previous value. That's again something that we discussed in the previous two things. I'm just going to copy whatever value is there previous, and that'll be if the index of this process is greater than 1. Only then I can copy the previous value, correct? So if I is greater than or equal to 1, I'm just going to go ahead and tracker of I will be nothing but list of tracker of I minus 1. Yes, that makes sense. Now I'm going to check for page fault, right? That will just simply say if process is not in tracker of I, not is won't come, only not in tracker of I. In that case, well, there's two cases there, right? First, initially, if it's just empty, just fill this up, right? That's what we're doing in these cases, and then only we're actually doing the rest of the logic, right? So let's go ahead and define the first case over there. Anyways, there's going to be a page fault, so we can just do page fault is equal to plus equal to 1. But initially, if there is nothing over there, it is empty in tracker of I, right? In that case, what you do, you just go ahead and take the index of this empty element. So that will be tracker of I dot index of this empty element, and then replace that. So tracker if I of ind will now be the process. Okay, and if not, right, that's where the page fault and this the algorithm really comes into place. The element to replace, that's something that we talked about previously also, that'll be none initially. Similarly, the index to replace, let's say that also to be none initially. Okay, so what I will do for p in tracker of I, so these are all the processes in the tracker currently at that time state. Everything in the frame is what the processes that are there in the tracker. Okay, what I'm going to do is, if this p is in process s of I plus 1, okay, to end of the process. Okay, I'm checking everything. In this case, if 4 is the p of I, process of I, I'm going to check everything from here to here. Okay, I am going to do temporary index. This will be nothing but processes of I plus 1. Okay, so this is where we're taking dot index. Okay, this will be until the end of the process list dot index of p. If you feel like this is a bit overwhelming, I can actually change this to remaining, and that can just be processes of I plus 1 to the rest of the process tree. So I can just check whatever is there in the remaining, and I can change this to remaining dot index of p also. Now once I'm able to get that, I can just check if this index to replace is none, right, or this index to replace is actually lesser than the temporary index. In that case, what I will do, the new index to replace will become the temporary index, correct? So if the process not there in the remaining, what I will do, I'll just set the element to replace to be the first element I get in the tracker. So that'll be what this looks like. So I'm just replacing the first element, right? That's what I'm doing here. Once I'm able to get that, what I will do is I will just check if this element to replace is none. That means this part has not gone through. I only have the index. Now I have to determine what element it is. In that case, what I will do is, so I will check whether the index to replace is also none. It won't be in most cases, but I think in the last, that would be a terminal condition somewhere. So I'm just going to do that anyways. Let's just set the element to replace to be tracker of I of 0th element. Okay, or let's do an else. That's where we actually find out what we're going to be replacing. So the element to replace will be whatever is there in remaining. So that'll be remaining, but remaining is not in the scope. It's there inside this for loop. So I'll just go ahead and take processes of I plus 1 to the end dot, sorry, of index to replace, because we know the index already. That's what we have found out here, right? So I can just do this directly. I know what element I'm going to be replacing this with. Once I know what element I'm going to be replacing this with, I can just go ahead and do an index that will be in the tracker of I. What is the index of the element that I'm going to be replacing this with? Okay, once I'm done with that, I just go ahead and do the replace functionality. That'll be nothing but tracker of I of this index will be equal to the process of this iteration. Okay, so first of all, I'm going to bring this one inside because it should be with after the for loop ends in this else condition when it's not empty. And then I'm going to maybe we'll add one break here. Okay, so if p is not there in the tracker, it will just go ahead and break after the first time itself, so that it doesn't go through the other elements in the tracker. We could save some computational space over there. If the element to replace is none, that is, if it is something within this, let's go ahead and do all of this. But else, if we already know that what the element is, let's go ahead and add an else condition. Let's just check the element index, that be tracker.i.index of this element that we're going to be replacing. Once we get that, let's just actually do the replace functionality. That be tracker of I of ind equal to process. Okay, so once we're done with this, just that's it. Let's go ahead and print optimal page replacement. Let's go ahead and print the page false, and then that will be the number of page fault, right? And then let's just go ahead and do for I in tracker. I'll just go ahead and print the I, right? Once I'm able to do that, let me just copy and paste this right here. Set this to optimal page replacement. Just comment this out right now and let's go ahead and see what that looks like. Okay, so you can see that initially it's 0 minus minus 0 3 minus, that's the same thing, 2 3 1. So 2 3 1 2 4 1 2 4 1 2 4 1 three times. Let me just go back to this. 2 4 1 2 4 1 2 4 1 three times, then it's 3 4 1 3 4 1, yes, and then it's 0 4 1, it's 0 4 1, and then again it's 0 for 1. Therefore, we've achieved optimal page replacement, and that is the code for this. I hope you're able to understand how we're doing this. In fact, in your exam, they'll actually give you one of these processes, or you can just randomly generate this also, and what they will ask you to do is to do the same with FIFO, with LRU, and with optimal page replacement. So just run through all of that. You can just see what it looks like in different page replacement algorithms, and you can showcase that as your output. I really hope this video helped you. You're able to understand a lot of these things. If it helped you, hit that like button, and thank you so much for watching. With this, we complete the operating systems course. I don't think I'll be doing any more videos. Yeah, thank you so much for watching. I'll see you in another video, maybe in another series. Until then, bye.